Hi, this is Priska from EC third year. Today let us see about the concepts of TCP and UDP. TCP, which stands for Transmission Control Protocol, is one of the core protocols in computer networking. It ensures reliable and ordered delivery of data between two devices over a network. It works on the transport layer that it takes the message from the application layer and it divides the message into segments, and then the segments transmitted to the receiver. So it is a transport layer protocol. It is a connection oriented protocol. This protocol is used with an IP protocol. IP is nothing but the internet protocol. So together they are referred to as TCP or IP suite. The process is divided into two sides. First one is sender side. TCP divides the data into several packets. TCP provides the numbering to these packets because we want to identify which packet to be transmitted. So we want to number the packets. The number is called sequence number. Finally, TCP transmits these packets to the destination. Next one is receiver side. TCP on the receiver side. TCP will reassemble the received packets and transmits them to the application layer again. This is the diagrammatic representation of data which is to be taken from the application layer and transmitted to the network layer. First we have the transport layer, that is end-to-end connection. Host A to host B, that is sent to receiver B. And then the application layer has two layers, upper layer and lower layer. Transport layer takes the data from the upper layer of the application layer and then it divides into segments. Then the divided segments is transmitted to the network layer. Connection establishment. Before data can be transferred, a connection must be established through a three-way handshake. The initiating device, that is client, sending a synchronous packet to the server. The server responds with the synchronous with acknowledgement packet and the client acknowledges the acknowledgement packet. Next, data transfer. Once the connection is established, then data can be transmitted. For transmission, each segment is assigned with a sequence number so that a receiver can reorder the packets with the sequence number if they are in out of order. TCP also provides flow control to prevent overwhelming the receiver with data by using the techniques of sliding window. Acknowledgement. After receiving each segment, the receiver sends acknowledgement back to the sender. If the sender does not receive acknowledgement with a certain time, it assumes that segment was lost and retransmit it. This ensures reliability. Error handling. TCP includes error detection and error correction mechanism. If the data arrives with errors, it will be discarded by checksum and the sender will be notified to resend the data. Connection termination. Once the data transfer is complete, then the connection is terminated through the four-way handshake. The client sends a finish packet indicating it has done sending data. The server acknowledges the finish with an acknowledgement. Then the server sends its own finish and the client responds with an acknowledgement. This ensures the termination of the connection. Here is the diagram for TCP connection establishment. Now we move on to TCP header. Each divided segment has TCP header. First, source port. Source port has the 16-bit field. It identifies the port of the sending application. The next one is destination port. It also has the 16 bits. It identifies the port of receiving application. Next, sequence number. We already know about the sequence number. It has 32-bit field. TCP assigns unique sequence number for each segment. This field contains a sequence number of the first data byte. Acknowledgement number. Acknowledgement number has 32-bit. It acknowledges to the sender. The receiver sends an acknowledgement back to the receiver. Next one, header length. Length specifies the entire length of the protocol, whatever the protocol may be, TCP or UDP. It has a 4-bit field. It contains the length of the TCP header and also helps to know where the actual data begins. Next, reserved bits. It has 6 bits for each. First, urgent. If urgent field is set to 1, then the segment is the first priority to transmit. Next, acknowledgement. If it is set to 1, it sends the acknowledgement to the sender. Next, PSH push This field is if this field is set to 1, then the data in the buffer is transmitted to the receiver side. RST next restart. If restart is set to 1, the receiver terminates the process and restarts the function again. Next is synchronous. The sender sends the data by a synchronous manner. Next FIN finish. If the finish field is set to 1, then the sender terminates the process completely. Next one is window size. It has 16-bit field. It contains the size of receiving window of the sender. We want to know the capacity of the receiving window so that it can receive the data as much it could. Window size is also used for flow control. Next one, checksum. It has 16-bit field used for error control. It verifies the integrity of data in the TCP payload. The sender adds the CRC checksum, that is cyclic redundancy check, to the checksum field before sending the data. If it fails the CRC check, then receiver rejects the data. Next one is urgent pointer. It indicates how much data in the current segment counting from the first data byte is urgent. Urgent pointer has 16-bit field. If the urgent pointer is set to 1, then this field is considered as valid. And last one is option. Option field is used for several purposes. For padding, parameter negotiation. Advantages of TCP. It provides a flow control mechanism using a sliding window protocol. It provides error detection by using checksum and error control by go back and ARP protocol. ARP protocol is nothing but address resolution protocol. It is a protocol that connects an ever-changing internet protocol address to the fixed physical machine address. Next, it eliminates the congestion by using a network congestion avoidance algorithm that includes various schemes such as additive increase, multiplicative decrease, slow start, and congestion window. Congestion occurs in case of traffic overloading when a link or network is handling the data in excess of its capacity. Disadvantages of TCP. Its performance is slower than UDP. Overhead means any excess usage of computing resources such as processing, memory, or bandwidth. It is not ideal for loss. It is not well suited for unidirectional communication, and the connection setup is also overhead. Features of TCP. TCP is connection oriented and also it is reliable protocol. It ensures the data reaches intended destination in the same order it was sent. Next, it provides a flow control and quality of service. It also provides a full duplex server that it can perform both role, receiver as well as sender. It provides error checking and a recovery mechanism. TCP establishes connection between two remote points before sending actual data. UDP or User Datagram Protocol is one of the core protocols used in computer networks. It provides a lightweight and connectionless communication method. It is also a transport layer protocol. It is a part of Internet Protocol Suite, so referred to as UDP or IP site. UDP is an unreliable and connectionless protocol, so there is no need for connection establishment. It simply takes the data, attaches its header, and sends it to the user. UDP permits delayed packets to be dropped. Delayed packets is nothing but the package takes the more amount of time to reach us from source to destination. UDP has no error checking, so it saves bandwidth. UDP header. UDP header is a 8 bytes fixed and simple header. This 8 bytes contains all necessary header information and the remaining port consists of data. UDP port number fields are each of 16 bits long. The range of port numbers between 0 to 65535. Port number 0 is received. Port numbers help us to differentiate the requests or processes from the different users. Just go through the diagram. First one is source port. Source port has 2 bytes, that is 16 bits long field used to identify the port number of the source packet. Next one is destination port. It also has 16 bits long field used to identify the port of the destination packet. Next, length. We already know about the length. It specifies the entire length of the protocol, it including the header and the data. It also has 16 bits field. Next, checksum. Checksum is a 2 byte field used for error control. It is calculated on UDP header, encapsulated data, and IP pseudo header. Checksum calculation is not mandatory in UDP because in UDP there is no error checking. Advantages of UDP: it is flexible, so it has the ability to adapt its state to satisfy the new demands. It is connectionless. It has a broadcast and multicast supports, so it can send the message to all recipients simultaneously, and it can send the data to the group of target recipients. Next, UDP is simpler than TCP and low overhead. UDP has minimal header information, making it more efficient in terms of data transmission. Disadvantages of UDP: it is not suitable for real-time communication, while the TCP is suitable for real-time applications. Inefficient for large data transfers. It has no order guarantee, so it is lack of reliability. Next, it is a limited error handling and no flow control. Features of UDP: it is good protocol for data flowing in one direction. It is not connection oriented. It does not provide congestion control mechanism. UDP is stateless and does not guarantee order delivery of data, so it is not reliable. UDP is simple and suitable for query-based communication. Query is the request of or data or information from the database table or communication of tables. Applications: UDP is commonly used where very small amount of data to be transmitted. Applications which requires one response for one request uses UDP. Routing protocols like RIP and OSPF uses UDP because they have very small amount of data to be transmitted. TFTP uses UDP to send very small sized files. Real-time applications like chatting and online games uses UDP, and also broadcasting and multicasting application also uses UDP. And the last table is the difference between TCP and UDP based on parameters like connection. In TCP, it is connection oriented protocol, while UDP is connectionless protocol. TCP is slower in performance, while UDP is higher. Error detection is possible in TCP. It is not possible in UDP. Data packets are arranged in correct order in TCP. In UDP, data packets are independent of each other, so there is not any flow of sequence. In TCP, there is an acknowledgement segments, while in UDP, there is no acknowledgement segments. TCP uses protocols such as synchronous with acknowledgements. In UDP, there is no handshake because there is connectionless protocol. Reliability: successful deliverance of data to destination router is reliable in TCP. Deliverance of data to destination router is not reliable in UDP.